So one theorem that we have looked at previously and we will continue to look at in this course and beyond is the Pythagorean theorem, and that says that in a right triangle with hypotenuse c, a squared plus b squared equals c squared. And we're going to use this formula in a variety of different ways, and here's one of them. It says that if a diagonal of a square is 12 inches long, how long is the side of the square? So I'm going to define my variable. I'm going to let s equal the length of the side of a square. And I'm going to draw a picture. Now, one of the nice things about a square is that each one of the corners is a right angle, and also the lengths of the sides are all the same. Now, the diagonal in this particular problem has a length of 12 inches. So for this problem, I'm only going to pay attention to this half, right? Because when I cut this square in half, I have a triangle. In particular, I have a right triangle. And the nice thing about it is that both the legs that are not the hypotenuse have length s. So basically, I can just go right into the quadratic formula, not the quadratic formula, the Pythagorean theorem, and come up with the equation that s squared plus s squared is equal to 12 squared. And when I simplify that, I get that 2s squared is equal to 144, which means that s squared is equal to 72. Now if I square root both sides, technically I have to do a plus or minus on the right hand side, but we're talking about the lengths of sides. So lengths are always going to be positive, which means that s is going to be the square root of 72. But when I simplify that, I know that 72 is 36 times 2, which means that s simplifies to 6 root 2. Okay. Now, another way that we can use the Pythagorean theorem, let me scroll down here, is to prove something or to disprove something. And here's sort of an additional variation of the Pythagorean theorem, and it says that if the sides of the triangle satisfy the relationship a squared plus b squared equals c squared, then the triangle is a right triangle. So if we can show that the triangle satisfies a squared plus b squared equals c squared, then we're done. If the triangle does not satisfy that relationship, then it's not a right triangle. So here we're going to use the Pythagorean theorem to decide whether a triangle with the given sides is a right triangle. So here, let's take a look at the information that's given on the left-hand side. We have a leg with 5 inches, a leg with 8 inches, and a leg with 13 inches. So just for the heck of it, just so that I can kind of visualize what's going on, I'm going to draw a triangle, and I want to know if that's a right triangle. And I can't just eyeball it because I just drew it, and I can make it look right if I wanted to. But what I want to know is if a squared plus b squared equals c squared. Is this a true statement? Well, 5 squared is 25, and 8 squared is 64. I know that 13 squared is 169. Do these equal? Well, if I look at the left-hand side, 25 and 64 is what, 89? Is 89 the same thing as 169? No. And since this triangle does not satisfy the Pythagorean theorem, it is not a right triangle. Okay. So I have to use the Pythagorean theorem to disprove that this is a right triangle. Okay, let's take a look at B. I have 5 inches, 12 inches, and 13 inches. So 5, 12, and 13. So if I can get this to satisfy the Pythagorean theorem, then I have shown that it's a right triangle. So is 5 squared plus 12 squared equal to 13 squared? And it's important to put these question marks here because I don't know yet. Okay, that's what I'm trying to show. So 5 squared is 25, 12 squared is 144, and 13 squared is 169. Now, does the left-hand side equal the right-hand side? Well, 25 and 144, that actually looks like 169. And 169 is equal to 169. And so, yes, this is a right triangle. So we can use the Pythagorean theorem to show whether or not a triangle is a right triangle. We can also use it to find unknown lengths of triangles. Okay, so it's multi-purpose, and it will continue to have more purposes. So it's important to memorize and understand what the Pythagorean theorem is saying.